Let's look at the domain of a function and the intercepts of its graph. For example, let's find the domain of f and any x or y intercepts of its graph. Let's start with the domain. What's under the square root, namely this x plus 4, has to be greater than or equal to 0. Or subtracting 4 from both sides gives us that x has to be greater than or equal to -4, which is the domain of f. So let's write that in interval notation. Domain of f is equal to, x has to be greater than or equal to -4, so close bracket at -4 up to infinity, which would be the domain. Now what about the intercepts of its graph? Well, let's let y equal f of x. In other words, y is equal to the square root of x plus 4 minus 1. Let's start by determining whether the graph of f has any x-intercepts. Well, an x-intercept, if it exists, is the x-coordinate of a point where the graph of f intersects the x-axis. And on the x-axis, y is equal to 0, isn't it? Therefore, if we set y equal to 0 in our equation, we can see if there's any x-intercepts. Doing this gives us 0 is equal to the square root of x plus 4 minus 1. And adding 1 to both sides, we get 1 is equal to the square root of x plus 4. And then squaring both sides, we have 1 squared is equal to the square root of x plus 4 squared. Or 1 is equal to x plus 4. And then subtracting 4 from both sides gives us x is equal to -3. So the graph of f does have an x-intercept. All right, what about the y-intercepts? A y-intercept, if it exists, is the y-coordinate of a point where the graph of f intersects the y-axis. And on the y-axis, what does x equal? It equals 0, doesn't it? So we set x equal to 0 in our equation here and solve for y. So we have y is equal to the square root of 0 plus 4 minus 1. Or y is equal to 2 minus 1, or y is equal to 1, which is the y-intercept of the graph of this function. Now, can the graph of a function have more than one x-intercept, or more than one y-intercept? There can be more than one x-intercept, but there cannot be more than one y-intercept. Because if this is indeed a function, then when x is equal to 0, there cannot be two different outputs for y. So therefore, there can be at most one y-intercept. All right, let's see another example. Again, let's find the domain of this function f and any x or y intercepts of its graph. We'll begin with the domain again. The only issue with this function is if the denominator were equal to 0. So when does x squared minus 4 equal 0? This means that x squared is equal to 4, or x is equal to plus or minus 2. So we must exclude these values. That is, the domain of f, again written in interval notation, is -infinity up to -2, open parenthesis, because we cannot include -2, union, again, open parenthesis at -2, up to 2, again, open parenthesis, union, open parenthesis, 2 up to infinity. And now, to find the intercepts, again, we'll let y equal f of x. In other words, we have y is equal to x squared minus 9 divided by x squared minus 4. So let's start with the x-intercepts, which we can find if we set y equal to 0, which means we have 0 is equal to x squared minus 9 divided by x squared minus 4. Now, a fraction is equal to 0 when the numerator is equal to 0 and the denominator is not. So where is our numerator? X squared minus 9 equal to 0. This happens when x squared is equal to 9, or x is equal to plus or minus 3. And neither of these values make our denominator here 0. So they're both x-intercepts. And let's see if the graph of f has a y-intercept. Which we can find by setting x equal to 0. In other words, we have y is equal to 0 squared minus 9 divided by 0 squared minus 4, or y is equal to 9/4. So the graph does have a y-intercept. And this is how we find the domain of a function and any x or y-intercepts of its graph. Thank you, and we'll see you next time.